Yes, today we will look at the equation. What is an equation? Equation is something like that. So when you are in 4th grade or 5th grade, you learn something like that. You have a square plus 8 equals 10. And then you know that you shall think about what number shall be inserted here to make it equal. So an equation is always the left side should be equal to the right side, yeah? And of course, this is with reference to numbers. So there should be the same number here. Number equals number, a specific number. However, when you look at it a bit closely, and this understanding is important for later stages, you have here a square and a number, and on the other side a square. So this can't be equal on the first glance. This can't be equal, right? Because when you have something different from a number, and on the right side a number, this can't be equal. So on the first step is to think about it as that this equation is already solved. So there is already the right number here inserted. So it is true that the left side equals the right side. So this is one way to look at it. And another way to look at it is, as we know from our parallel world model, right? So we have the parallel world on top, and at the bottom the normal world. And this is an idea from the start video, and it's also an idea from the video concerning the variable. So please watch both of those videos to understand what I'm now doing. So there you learn that we have, in the normal world, we have signs. For example, the square, or for example, letters, X, Y, and so on. And they refer to what we call the variable in the parallel world. And I try to redraw it. As you can see, I'm not the best drawer in the world. My graphic designers are much better. But here you can insert now numbers, right? And the right number for this equation, probably you have already noticed that, is 2. So when you insert 2 in this box, this square in the normal world will be square equals 2, right? Then it makes sense, right? So there is this 2 inserted in the box, and then you say, okay, this kind of refers to this box, right? But before, when you look at it at a first glance, it doesn't seem to make any sense, because when you have something like that, square equals 2, it doesn't make any sense, right? So another interpretation of that is that when you solve equations, you think about the equation sign as something like that the equation sign forces whatever is on the left side to be equal to on the right side. Yeah. So the equation sign is kind of a force, and it's kind of a dictator that says you have to be equal even if you are not, because at a first glance, right, those two, they are unequal, a square and a number. Or as you have it with x equals 2, same thing, right? On the left you have a letter, and on the right you have a number, and this can't be equal. But the equality sign says, no, in this context, I say you have to be equal. The left side, the letter, has to be equal to the right side, the number. Why is this important to think about it in this way? So we grow up now a bit. We no longer use the square. We use now the x, right? It's the same thing. Square or x it refers to the variable in the parallel world. And now we solve this equation. What is the goal of, or how do we solve the equation? Well, we want to have the x that it stands alone, right? The x must stand alone, and in front of x, this is important for later stages of solving equations, there must be a 1 multiplied by x. This is always kind of hidden, always there, because you can always write 1 times x equals x, right? Because when you multiply something, no matter what it is, by 1, by the unit, it stays 1, right? So 1 times x is x. 1 times 5 equals 5. 1 times a equals a, right? So it doesn't matter. But it's important for solving equations that you think about it as there is a 1 in front of x. In our case, we are lucky. There is already 1 hidden in front of it because there's no other number. Another number would be, for example, 5 times x. So this is not the case in our equation, and so we don't have to worry about that. This is important for later stages. So this is already fulfilled. So we only have to see that, or we have to make sure that the x is stands alone on the left. Yeah, here there's still a number there. This number has to be gone. We don't need it here on this side. We need the x to stand alone, and there we have our number then. So what we do is we write a line, and we say let's remove the 8 from the left, and we can do that by making this 0. Yeah, we want to make that a 0 because when you add a 0, you can leave it out, and we do that by subtracting 8 from both sides. So whatever you write behind this line here, you have to do it on both sides, because the equation is like a scale, and a scale is also always usually in a state of equality, right? And so when you have a scale like this, right? So there's a heavy thing on the left and a less heavy thing on the right. When you want this scale to remain constant, right? So it doesn't change anything. So for example, you would put on this thing here, you would put 1 kilo, and on this thing you would also put 1 kilo, and then the scale does not change because you put the same kilogram on both sides. And this is the same for equations. You have to follow this rule. The equation, the sides have to be equal, and we make sure that this is the case. So we subtract -8, then we have x plus 8. You write down the old, what you have from the equation, right? And then you write down the new thing behind it, right? So this is the new thing. We did it on both sides, so we are safe now to follow the rule. And now we have the next line. How does the next line look? So we have x and 8 plus 8 minus 8. This leaves us with 0. So plus 0 equals 10 minus 8. This is 2. And now, as I said, we have plus 0. This is the thing we wanted. Because plus 0, we can always just leave it out, because it doesn't change anything if you add 0. So now we have x equals, and you write down the old, and now we have our solution, right? X equals 2. And when you look at it again closely, kind of recapturing what we said in the beginning, now x is read as a letter is not equal to the number 2, right? But if you read x as a sign that refers to the variable in the parallel world, it is equal to the 2 because in the parallel world 2 is in the box. And so the equality sign now means that I force you to be equal x to 2, and 2, I force you to be equal to this x. This is the interpretation, and now we can interchange x for 2, and we can interchange 2 for x, and we can put it into the x from the beginning, and now the beginning is also true, so we have the 2 already there. We have 8, we have 10, right? And now the equation makes sense and we solved it. So this is called our solution, right? Because the solution, it's a solution because it kind of solves our equation, because this was our problem, and 2 makes sure that we are correct, and this is the end result. Happy holidays.